Number 9 and 10. It's the same picture as the one we used in number 8, but now we're trying to find out how far things are moving and how fast points are moving. This has not, well, it does not directly relate to torque or force. We're just finding out speeds and distances. So number 9 asks, how far will a point on the outside edge of the smearing wheel move during each rotation of the big crank? So what that means is, as someone turns the crank from here all the way around and back to there, if you follow a point right there on the edge of the smearing wheel, how far is it going to go? Is it going to move this far? Is it going to move this far? And these distances need to be measured not as a straight line, but actually how far does it move through space. In order to answer these questions, you have to find a lot of circumferences, because all of these motions are happening in a circular pattern. So the distances things are traveling have to do with the circumference of the circle around which they're traveling. The first thing to do in number 9 is to find sprocket A circumference. The circumference of sprocket A is 2 pi times 0.02 meters. And that gives you 0.126 meters. So that is the circumference of sprocket A right there. So that would be if you lived on the edge of sprocket A and you made one full rotation, 360 degrees around this circle, you would have traveled 0.126 meters. And what that also means is that as this rotates, it's going to pull the chain along, and the length of chain that's going to get pulled along, I'll just try to eyeball it here. Maybe this. Let's just call that 0.126 meters of chain. So as this sprocket rotates one full time, it's going to pull that length of chain in. So that's what I've said here. Sprocket A turns once per rotation of the big crank, and a point on its edge travels 0.126 meters during this one rotation. So it moves the chain 0.126 meters. The next thing I found is sprocket B circumference. Again, the formula is 2 pi r. The radius of sprocket B is 0.83 meters. Is that correct? That is not correct. The radius of sprocket B is actually 0.8 meters. This is going to give us an approximate answer, but it's not going to be exactly right. So that really should be 0.8 meters. I messed up. But again, the answer is going to be pretty close. So the circumference of sprocket B is approximately 5.02 meters. So if we know that to go all the way around is 5.02 meters of distance, then as 0.126 meters of chain is unwound from this sprocket. If you imagine that I'm just going to take this much chain and draw, I'm going to shade in an area, let's just call that 0.126 meters. As you pull this way on the chain, and that much chain comes off, so what was here will now be there, this is not going to make a full rotation. We want to know how much of a rotation it actually makes. And the way to figure that out is, if this whole thing is 5.02 meters, then what fraction of 5.02 meters is 0.126 meters? That'll tell us how much of a rotation is made. Here's one way to write this out. I said a 5.02 meter length of chain would have to move, this means that a 5.02 meter length of chain would have to move by 4 sprocket. I think what I'm trying to write here is we're trying to find out how much that length of chain would have to move for sprocket B to rotate. No. Oh, it would have to move by. So, poor grammar. This means as 5.02 meters of chain moves by or passes by, sprocket B rotates once. So I've written 0.126 meters of chain. That is how much chain is actually passing by as the big crank is turned one time, multiplied by one rotation per 5.02 meters of chain. So a full rotation of sprocket B corresponds to 5.02 meters of chain. When you multiply these two together, we have meters of chain on top, meters of chain on the bottom, rotations on top, and it comes out to 0.025 rotations. But you could just say 0.126 meters divided by 5.02 meters. This is how much chain moves by. This is the full circumference of the sprocket. When you do this divided by that, you're going to get the fraction of a rotation. So this is how many rotations are actually made by sprocket B. So as this tiny amount of chain goes by, it doesn't make the full 5.02 meter rotation. It only makes 2.5 hundredths of that. Now, we still haven't gotten to the answer of how far will a point move on the outside edge of the smearing wheel. Smearing wheel circumference is 2 times pi times 0.83 meters. Calculated that before, I should have used 0.8, which is 5.21 meters. That's how many meters it rotates for a full rotation. If you multiply 5.21 meters times the number of rotations that are actually made by the sprocket, then you get 0.13 meters. So what this is saying, again, this is the fraction of a rotation that is made. So it's just turning 2.5 one-hundredths of a circle. It's not going all the way around. It's just going a little bit. And if you multiply that fraction by this whole distance, then you get the distance that it goes when it rotates that fraction of a turn. So you multiply the number of rotations times the circumference, and you get the distance traveled by a point on the edge.